All right, example one. We're going to be multiplying -4 1/2 times -2 3/4. And we just got done adding and subtracting all of our sign numbers and having the rules for adding and subtracting. You need to have those in one spot in your brain. And you need to have the rules for multiplication and division in a different spot because they're different rules. And the rules for multiplication and division involve the sign of the answer only. So for the same signs, we're going to be doing two numbers at a time. If you get the same signs, your answer is positive. If you have different signs, your answer will be negative. Every multiplication and or division is exactly the same answer it would be normally for that multiplication division. You simply have to assign the proper sign to the answer based on the signs in the problem. So if I'm looking at this problem here, and I see that the first number is -4 1/2, the second number is -2 3/4, those signs are the same, my answer will become a positive answer. So I know that immediately because I've got two negatives. And even yesterday we had a few people with this misconception, two negatives make a positive when we were doing the addition subtraction stuff. With addition subtraction, the bigger number determines the sign of the answer. When you multiply two negatives, make a positive. So make sure that you have the operation assigned to the rule properly. As far as multiplying, I've said over several days now that improper fractions are better than mixed numbers. When multiplying and dividing, they are always better than mixed numbers. Always. Never, ever, ever improper fractions are always better than mixed numbers. So if you have mixed numbers, make them improper fractions. We're going to multiply the whole number times the denominator. And we're going to add that sum to the numerator. The sign is not involved in all this process. So pretend it's positive. 4 times 2 is 8. 8 plus 1 is 9. So 9 over 2 is what 4/2 is. The minus sign is attached to that number. And then I'm multiplying. I can put the X to show multiplication. Back-to-back parentheses also denotes multiplication. I'm going to multiply 2 times 4. And I'm going to add that to 3. Again, ignoring the sign when I do this. 2 times 4 is 8. 8 plus 3 is 11. So 11 over 4 is equivalent to to 2 3/4. We make it negative. Now it's equivalent to -2 3/4. So you want every single number in your multiplication or division statement to be an improper fraction, not a mixed number. Now, when it comes to multiplying fractions, the first thing I want to do before I start multiplying is see if I can reduce the numbers. Sometimes you can, sometimes you can't. If you can, it's great. If you can't, that's fine too. But I'm looking at the top numbers 9 and 11 versus the bottom numbers 2 and 4, and I'm asking myself, does something evenly divide 2 or 4 that also divides 9 or 11? So the only prime number that divides 2 or 4 is 2, right? So if you stick to prime numbers, 2 goes into both of these numbers. Does 2 go into either 9 or 11?
No.
No. So this does not reduce. So once I've decided it does not reduce, now it's just a matter of multiplying. Multiplication does not require a common denominator. It's much friendlier than addition of fractions. We simply multiply the tops to get the new top. 9 times 11 makes 99. Multiply the bottoms to get the new bottom. 2 times 4 is 8. We already made the decision that it's positive because the signs are the same. That's my answer. And again, leave it as an improper fraction. Do not change it back to mixed number. It's unnecessary, and it causes one more step that could cause you to get a wrong answer. So this is the right answer. It's an appropriate right answer. Nothing's wrong with it. Leave it in its simplest form, which is this.